Hello, keen mathematical wizards and students. Time to do some more probability, so let's get into it. First of all, today we're talking about conditional probability. So, conditional probability is the probability of something occurring given that something else has already occurred. Now, these are the magical formulas. We're actually not going to use the formulas. We're going to use a scary thing called logic, which will actually apply the formulas. And I'll spend more time talking about that later on if you wish. But let's get into some examples. Okay, so here we have a Venn diagram, and we can see that inside circle A, there are 7 elements. 4 in A only and 3 that overlap from A and B. Inside circle B there are 8 elements, 3 that overlap with A and 5 that stand alone in B. And outside A and B we have 1 element. So first question we have is find the following probability that you would get something, an element, from circle A. So we look inside circle A. All of the numbers inside circle A, 4 and 3, both add up to give 7. So there is 7 out of 4 plus 3 plus 5 plus 1. So it's 7 out of 13 because 4, 3, 5 and 1 add up to give 13. That's what we've done normally. There's nothing new. Well, part B, nothing new here either. If we were going to choose some element at random, what's the chance that it would come from the intersection of A and B? Remember, the intersection of A and B is the overlap of A and B. So you would have 3 chances out of the 13 chances. That's not new either. Here's the first new part. This says, find the probability that you would get something from A given that it is guaranteed to be coming from B. Whenever you see a question like this part here, the second letter, means that's what it's out of. So if we look inside circle B, that's what everything is out of. The question is now saying, so let's get rid of all of that. We are focusing only on what is inside circle B. That's what this given that part means, that line that I've got underneath there. So if it's given that it's in circle B, what's the chance that you would get something coming from circle A given that it must be coming from circle B? So let's look inside circle B. When you're looking inside circle B, are any of these elements coming also from circle A? Yes, the 3 comes from circle A, given that it belongs also in circle B. So the answer to this question is 3 out of 8. Let's try the next one. Same concept, but things are reversed. This question says, find the probability that you would get something that belongs to circle B, given that it must come out of circle A. If it must come out of circle A, it must come from in this section here. So the question now says, what's the chance that you would get something that belongs to circle B, given that it comes out of circle A? Well, this is the part here that belongs in circle B that comes out of circle A. So you've got 3 chances out of 7 because there are 7 elements in circle A. Fairly tricky stuff. Let's look at our second example. From a group of 17 hockey players at a game of hockey, 14 played on the field, 8 sat on the bench, 5 both played and sat on the bench. If we choose someone from random, fill the information in on the two-way table first. Okay, so A stands for the person played on the field, B stands for the person sat on the bench. Well, let's actually fix that up a bit. A stands for the person played on the field. So A is they played, which means the complement of A means they must have not played. B stands for the person being on the bench, which means the complement of B means they were not on the bench at all. So let's actually have a look at our players here. The bit that I want to focus on first is this bit here. 5 both played and sat on the bench. If 5 both played and they were on the bench, here's played, here's the bench, played and on the bench, that means we must have a 5 in there. And there's our 5. I put a 17 down here first up because there are 17 hockey players altogether. So 5 played and they were on the bench. The next thing I want to look at is this part here. 8 of them sat on the bench altogether. Well, let's actually have a look at this. This row is the bench row. And we know 8 players sat on the bench. Well, I've got 5 players sitting on the bench here. If 8 players sat on the bench in total, I need to get another 3 players there, and 5 and 3 add to give 8. Now we're going to look at this part. 14 played on the field. If 14 played on the field, this is playing on the field, this column here. I've already got 5 that have played on the field. 5 plus 9 is 14. And 5 and 9 do add to give 14, so that represents all of the people that played on the field. Now I know there's a grand total of 17, so 14 and 3 makes 17, and 8 and 9 makes 17. And then when I look for the last part, this is people that did not play and did not sit on the bench. Well, there's none of them, because if we look at this column here, 3 and 0 add to 3. If we look across here, 9 and 0 add to give 9. I do a double check here. Those are the numbers inside my table. They should add up to 17. 5 and 3 are 8. 8 and 9 are 17. And the 0 doesn't change it, so 17 is correct. That is my two-way table labelled. Now I can start answering some questions. Part B says, find the probability that the person only sat on the bench. They only sat on the bench. Okay, so that means we want to go to B. If we go to the B value, they only sat on the bench would have meant they did not play. So only sitting on the bench, these are all the people that sat on the bench. There were 5 that sat on the bench that played, and there were 3 that sat on the bench that did not play. So we've got 3 chances out of the group of 17 players. Let's look at part C. Find the probability that the person sat on the bench given, there's that word, given that they played on the field. So they sat on the bench given they played on the field. So we know, we're guaranteed that they played on the field, which means we are dealing with, if they played on the field, we are dealing with this column here, because they're the column, that's the column that represents people that played. So they sat on the bench given they played on the field. If they played on the field, we're only drawing from this because the word given was used. If we're only drawing from this, how many of those people sat on the bench? 5 of them did. So 5 out of the 14 that played sat on the bench. So we get 5 out of 14. Our final question. Find the probability that the person played on the field given that they sat on the bench. Again, this word given. And it was given that they sat on the bench. So let's come over here. This row here represents people that sat on the bench. So when we're dealing with this question, we're only looking inside that row there. So how many people played on the field given that they come from people that sat on the bench. Well, these are the people that sat on the bench. How many of the people sitting on the bench played on the field? 5 of them played on the field that sat on the bench. 3 of them that were on the bench didn't play at all. So we're interested in 5. 5 that played on the field, so it's 5 out of the 8 people in that row. So it's 5 out of 8. So it's a bit of a challenging concept, this given that. Time for you to try doing some questions and see how you go. And if you struggle, I will help you next class. Enjoy. Bye for now.